percentages. Now, percentages, of course, are just a breed of fractions. If we are thinking about percentages, one way of thinking about them is if we say 1%, what do we mean? We mean 1/100th. If we say 50%, we mean 50/100ths, and that can be, if we feel comfortable with fractions, remembering the sort of the conversion back and forth between percentages and fractions can be helpful in lots and lots of situations. There are two formulae that we need to sort of be fully conversant with. The whole times the percentage equals the part, and lots of GMAT questions hinge on, well, they tell you the whole, they tell you the part, they ask you what the percentage is, they tell you the percentage in the part, and they ask you what the whole was. You get the idea. Slightly more challenging is the formula for percentage change. Now, I strongly recommend that you remember percentage change in this format, new minus old divided by old. If you look in a book, I think even in our book, it says x minus y divided by y. Well, that's fine, but often it can get a little bit confusing about which number is x and which number is y. And all percentage changes have some kind of chronological components that happen over time. So if you think of it as new minus old divided by old, then you'll know where you are in terms of that. So let's just look at a couple of key issues. One of the key issues I mentioned, it can be helpful to be thinking about percentages in terms of decimals, percentages in terms of fractions. One of the many things that it's important that you remember, and that you memorize on the test, are these decimal equivalents. As soon as you see the number 0.143, then it should immediately jump out at you that that's the same as 1/7. If you see 14.3%, again, you should immediately think, oh, that's 1/7. Similarly, you should be equally able to do the conversion the other way around and say, well, if I'm dealing with 1/11, that's the same really as about 0.09. And this can be handy in lots of different situations where you're dealing with percentages. You'll have noted that, of course, with thirds, sixths, sevenths, ninths, 11ths, and 12ths, the decimal equivalents of the fractions are only approximate, because, of course, a third is 3 repeating, a sixth is 0.16 repeating, a ninth is 1 repeating, an 11th is 0.09090909, a 12th is 0.083 repeating. The joker in the pack is 1/7, because the decimal equivalent of 1/7 is about 0.14258 something. It can be useful to think about that, because sometimes you do get questions which focus on the issue of how many, if you multiply 11ths, 12ths, thirds, and sevenths by a certain number, which is going to have the most complicated set of repeating final decimals. So knowing that a 7th is the joker in the pack can come up and be an issue. So let's look at a few. I think that's it for our percentages review. Yeah. Let's look at a few practice at these practice questions here. What percent of 50 is 17? So if you go ahead and use whatever tool you like, Jan, to give us your quick calculation on that. Good, 34%, absolutely right. Okay, what about the next one? Remembering that the formula is new minus old divided by old. Okay, so far so good. 7/8 is certainly the answer. Can you convert 7/8 into a percentage? Remembering our decimal equivalents. Absolutely right. Okay. So this shows how, especially in percent change problems, being familiar with your decimal equivalents is very helpful. If you know that an eighth is 12.5%, then it's not too arduous to get that up to 87.5%, either by multiplying 12.5 times 7 or by saying, well, 7/8 is 1/8 less than 1. So 1 minus 12.5 would be 87.5%. Great. Okay, let's look